Solving trig equations. To solve a trig equation, we use the cast diagram and look for related angles, and those have both been explained in previous videos. What we're trying to do when we solve a trig equation is to find the angles, which are the x values, for a given y value. And this video is going to have a look at a couple of different examples. Example 1. Solve sine x equal to 0.5. Okay, so the 0.5 here is the y value, and this part here we call the domain. So that tells us that our x values must be somewhere between 0 and 360 degrees. And this obviously, this domain, can change, so it doesn't always need to be the full length of a wave. Remember, the sine wave has a period of 360, so what we're saying is we're looking for any x values where the wave is equal to 0.5. And we'll have a look at the graph, first of all, before we start to solve it, to see how many answers we think we should have. So I've said that here y is equal to 0.5, and if we look at the graph, and the graph would be y is equal to sine x, we can see there will be two answers. So we mean two x values. I'm going to just quickly sketch the graph there. So there is y is equal to sine x. If we say that that is our half there, then if we come along and down, we can see that we're going to have an x value here. And if we go along further, we're going to see that we're going to have an x value here. So we have two x values on the graph of y is equal to sine x, which equals 0.5. So now we'll have a look on the next slide on how we would solve that. So we'll go back to writing it down. So we had sine x equal to 0.5. Now on the previous slide we had a look at the graph and we saw there was two values. We could also narrow them down to the quadrants that they were going to be in on the cast diagram, because we could see that they were both in the first half of the wave, so that meant it was quadrants 1 and quadrants 2. So when we come to solve a trig equation, we always want to think about our cast diagram and think about the quadrants that our x values are going to occur in. In order to do that, we have to think about whether the function is positive or negative. You can do what we just did there and draw the graph roughly if you want. That could be a way to work it out. But the other way is to just look at the sign of the y value. So for step 1 is sine x positive or negative. Okay, so you would ask yourself that. You don't need to write anything down here, but you would ask yourself, is the sine function positive or negative? In this case, we have positive. Okay, so then we go to our cast diagram, so that would be step 2. use the cast diagram to pick quadrants. And I've drawn my cast diagram up here at the top. So we've said, remember, we've got all sine, tan, cos, and we've said that our function is sine and it is positive. So where is sine positive in our cast diagram? It's positive in the first quadrant and it's positive in the second quadrant. So we now know that our answers, our x values, are going to be in the first quadrant and the second quadrant. And we did already know that by looking at the graph. But the cast diagram allows you to not have to draw the graph if you want. Okay, so that was steps 1 and 2. Step 3, I'm running out of space to put that on, so I may have to go to the next slide, I think. So I'll repeat what I had. We had sine x equal to 0.5, and we've got our cast diagram that we've now said it's quadrants 1 and 2 that we're interested in finding angles in. So step 3 is to take the inverse sine to find the value in quadrant 1. Right, so inverse sine is a button on the calculator. We did talk about this in a previous video. So you would be doing x equal to sine to the minus 1, that's what inverse sine looks like, of 0.5. And on the calculator, you would be pressing your shift and then your sine button. When we do that, we get 30. So that's 30 degrees, and that is the angle in the first quadrant. So we know that that there is 30 degrees. Now we're also looking for our second related angle, and remember from the last video, which was related angles, to find the value in the second quadrant we have to do 180 minus our x value, which was 30. So step 4, find the related angle. In the second quadrant. Okay, so to do that, we would have to do x is equal to 180 minus 30. So x is equal to 150 degrees. So our two answers for this trig equation are 30 degrees and 150 degrees. And that's how solved our first trig equation. Now, as we move through this, I will start to reduce the amount of writing that I'm writing here. I won't write all of step 1, step 2 each time, and show you really what it is that you have to write as a minimum to be able to answer these questions and to get marks. The next one is slightly different, so I will have steps in that, but the third example that I'll do will show you how I would normally work this out and lay out this answer. Okay, so example 2, we're going to solve 2 cos x equal to minus 1. Oh, that's not a very good x. There we go. And our domain is going to be again between 0 and 360 degrees. Okay, what you're noticing first of all with this equation is that there is a 2 in front of the cos x. Now, to solve a trig equation, you must have the trig function on its own on the left-hand side, really, of the equation. So we're going to have to move this 2 from the left-hand side to the right-hand side. And that's just transposition. So we're multiplying by 2 on the left-hand side, so we would divide by 2 on the right-hand side. So 2 cos x equal to minus 1 becomes cos x equal to minus a half. So that was step 1. rearrange. Rearrange for cos x on the left. Or if it had been sine x or tan x, you would have rearranged for that. But you want your function on its own on the left-hand side. Now, we need to again follow from what was step 1 in the last example and decide whether the function is positive or negative, and then the next step, decide on the quadrant. So we're doing the same steps now. So step 2 is cos positive or negative. And in our case, it is negative this time. So I've picked one that's negative to show you what you have to do here. And it is a little different. There is one extra step here. And then for step 3, decide on cast. Decide on quadrants using cast, I suppose is what I should say. Decide on quadrants using cast diagram. Okay, so we'll put that here because I'm going to have to move on to another slide anyway. So it's all sine, tan, cos. Right, so this time we have decided we have a cos function and the cos function is negative. So the first thing you should do when you look at the cast diagram is you to say, where is cos positive? Cos is positive in the first quadrant and the fourth quadrant. That's what the diagram tells you, A and C. So the actual quadrants that we are interested in for this trig equation must be the opposite to, because we don't want cos positive, we want cos negative. So it's actually the second and the third quadrants that we are going to use in this example. So I'll just write that there. Second and third. Right, let's continue on. So we had cos x equal to -1/2, and we had our quadrants in the second and the third are the two that we are interested in. Now this is where it changes slightly from the previous example because we have a negative function. Now the previous example, what we'd do now is we would take the inverse. So this time we would take the inverse cos, and we're still going to do that. However, we ignore the negative sign that we have here. So this negative sign, when we take the inverse, we ignore. So if I just say step 4, take the inverse sign, or inverse cos it is, sorry. Take the inverse cos to find the angle, in the first quadrant. Now we always want to find the angle in the first quadrant. We talked about that in the related angles video. So again, we're trying to find the answer to the first quadrant to then use that to find the quadrants we are interested in. So we ignore the negative sign. If we include the negative sign, it won't give us the angle in the first quadrant. It won't give us an angle between 0 and 90 degrees. So that's why we ignore the negative sign. We ignore it so that we get an angle between 0 and 90, which we can then use to find our related quadrant angles. So what we're going to write is x is equal to cos to the -1 of 1/2. So you can see that I haven't put that negative sign in there. So I'll just put a wee star there to show you that that's what we've done. We've ignored the negative sign. And what we end up with then is we end up in the calculator, when we do our shift cos this time, we get 60 degrees. So 60 degrees is the angle in this first quadrant here. But we are interested in the second quadrant, so we have to take away from 180 to get the second quadrant, and to get the third quadrant, we are going to add on to 80 to give us our third quadrant. So we're actually going to have to do additional calculations to find both of our angles this time. So the final step, step 5, use this value, that's the value from step 4, to find the remaining quadrants. And by remaining quadrants, I mean the remaining angles, the related angles in those other quadrants. So we had x is equal to 180 plus 60. I should have done the takeaway 60 first of all, but anyway, I've went with this one. So that's 240, and x is equal to 180 minus 60, which is 120. So I got there in the end, round the wrong way, but this is our second quadrant, and this is our third quadrant there. So x, the answers to this equation are x is equal to 120 degrees and 240 degrees. And that is our answer when we are solving the trig equation 2 cos x equal to -1. So just to stress that when you have an example where the y value is negative, the negative sign is really just to tell you which quadrants you need, and then you ignore that when you're taking your inverses, because we're interested in finding that value in the first quadrant to use it to find our related angles. Okay, and let's have one last example. This last example, I'm going to write any of these steps now, so I'm just going to go through the working in the way that I would normally write this, and this is really how we're looking for you to present these questions. Example 3. Solve 3 tan x equal to 1, and again we're going to have a domain between 0 and 360 degrees. So first of all, I'll write 3 tan x equal to 1. Okay, so we don't have the trig function by itself on the left hand side, so first of all I divide by 3. So tan x is equal to 1/3. At this stage, I say to myself, but I don't need to write anything down, is the function negative or positive? Well, it's positive. So the only thing I'm going to write is I'm going to then decide on my quadrants based on that. Well, where is tan positive? Tan is positive in the first quadrant, and it's also positive in the third quadrant. If you need to add the all sine tan cos, the A, the S, the T, and the C part to your cast diagram, that's fine. Now that we've decided on our quadrants, we take our inverse tan. So it's tan to the -1, which would be our shift tan on the calculator, followed by 1 divided by 3. That gives us an angle of 18.4 degrees. Now I've rounded that to 1 decimal place. The question might tell you what you've to round it to. If it doesn't, pick 1 or 2 decimal places, something sensible, and make sure you're rounding correctly. Okay, that is the first quadrant, and that is one of the answers to this question. So I'm interested in finding out the next answer, which was quadrant 3. So I need to do 180 degrees plus my 18.4. So I end up with 198.4 degrees. So my final answer is 18.4 degrees and 198.4 degrees. And that's us. And you can see that all of that working was done in one slide there. So really it doesn't require, at this stage, a lot of working. And just try to keep it neat, laid out well so it's easy to follow when you're marking it. Now, solving trig equations do get harder. These are the basic trig equations that you would expect to have learnt in, say, National 5 Maths or Standard Grade Maths or Intermediate 2 Maths. At the next level up and at level 6 and 7, you would be expected to be able to do these trig equations without any difficulty, because we're going to advance on those, and that's what the next videos are going to start to look at. What else do we do when we're solving trig equations? How can they get harder, or what makes it harder? And they're to come shortly.